All right, guys, welcome back. We're on day 7 in your packet, converting points that are given to us in rectangular XY, and we got to convert them to polar. On day 5 last week, I gave you guys polar coordinates, r comma theta, and said, hey, could you give me what it would look like on the XY graph? And if you guys remember, we used these formulas right here. If you wanted the x coordinate, you do r cosine theta. If you wanted the y coordinate, you would do r sine theta. All right. It's going to be a little bit more involved today when we hit the reverse button. All right. So I'm going to give you an XY and say, hey, could you guys put it in polar for me? All right. It's a little bit more involved than just knowing two formulas. Okay. Couple things before we get started. When you find the r value for your polar coordinate, it must be, and take a look at my restrictions here, it's got to be greater than 0, which basically means it's got to be positive. Okay, no negative r values here, always has to be positive. And then theta, all right, this is something to definitely be aware of today. Theta has to be in radians. No degrees allowed when you write a polar coordinate. Okay, it has to be in radians, which means if we're in degrees, we're going to have to convert it, which I'll review with you. We did earlier in the unit, and I'll review with you as we go through today. Okay, so take an XY and giving me r comma theta. That's today's goal. Now you'll see we only have 3 problems, so you're probably thinking it's a smooth one, but it's going to be pretty intense here. And hopefully I don't lose your focus here. I'll try to make this as quick and detailed as possible. All right, so for number 1, we are given this coordinate right here, -2, 0. What I want you to do every single time today is to graph that rectangular coordinate. So here's my little quick ghetto graph, right? If I said, hey, where's -2, 0, where would you put it? You'd say, oh, -2, right here, 0. So there's where that point would be. And now what I'm asking you guys is, if I put that on the polar graph, where would it land? Okay, so again, polar coordinate is r comma theta. R is the distance from the pole, the origin, to your point. So hey, this is all I'm asking here. What's the distance from the origin, the pole, to the point? We don't need to do anything special. That's a distance of 2, isn't it? So we got our r value already. It's 2. Now what about theta? Okay, where does this angle lie here? Well, remember, as you go around the circle here, right, as we go counterclockwise, you guys got 90, you got 180, you got 270, and then I go back to 360. So this point is on what line? It's on the 180 line, right? It's on the 180 degree line. But remember what I said before at the beginning, it's got to be in radians. Got to be in radians. So do you guys remember what 180 was equal to as far as radians go? I'm hoping maybe 180 was equal to pi radians. Okay, pi radians. So this one wasn't too bad. The point here in polar was 2, comma, what was my angle in radians? Pi. So 2 pi. All right, not bad. It's not that bad when it lands on one of the axes. All right, but that's not going to be the case, as it's going to be for 2 and 3. So I need to actually get a little bit more detailed here. All right, so again, find the polar coordinate. Here's my rectangular coordinate, -1, radical 3. Please throw it on a graph for me. All right, so, and again, you don't have to be exact, but what quadrant would -1 on the x, radical 3 on the y be? That would be somewhere in the second quadrant, because here's -1, and, we'll say that's radical 3. Okay, so somewhere there. All right, so again, I want to get r comma theta out of this. All right, it's a little bit more involved than number 1. So if you ever need to reference steps because you forgot them, they're all up here. 3 simple steps. Plot it, which we did. Now remember, when I go to find the r value, that's the distance from the origin to that point right there. That is my r value. I need to find that length. And how I'm going to find it is I'm going to make a right triangle out of this and do Pythagorean theorem. Well, how can I do Pythagorean theorem if I don't even know the other sides? You do. You know the other sides. Ready? This horizontal side is a length of 1 because you went from 0 to -1. The vertical leg is radical 3 because look, you went up to radical 3, right? Makes sense. All right, 1 radical 3. So if I did Pythagorean theorem right now to find this r value, it's 1 squared plus radical 3 squared equals r squared. A squared plus b squared equals c squared. So here we go. I got 1 plus 3 equals r squared. R squared equals 4. So your r value in this case, 2 units. 2. All right. Theta now is going to be a little bit harder to determine. All right. First of all, what am I talking about when finding theta? I am talking about from the first quadrant to the second quadrant. What is that angle measurement? And it's got to be in radians at the end. All right. What is that angle right there in the second quadrant? Well, I'm not going to be able to find that right away, but I'll tell you what I can find is how about the reference angle right here? How about that reference angle I just put in purple? I can find that. And then if I knew that angle, you're darn right I could find what theta is in the second quadrant. All right, so how do I find the reference angle? That is step 3 up here. We're going to find it by using tangent. And this is going to be going way back earlier in the year for review. So we're going to say tangent of theta is equal to, now remember, if you thought SOHCAHTOA, theta was equal to opposite over adjacent. So tangent, theta, go back to our triangle. What is opposite my purple angle? A side length of radical 3. And what is adjacent to my purple angle? That's 1. But be careful you don't get caught into this, guys. Remember, this is going this way on the x-axis, so that's got to be a -1 there. Watch out for that. Should the x and the y be negative, both, one or the other? All right, it's got to be -1 because you're going towards the left. And now to find theta, that reference angle, what I'm going to do, and again, this is old school here, going to go to the calc, so make sure you either have your Chromebook calculator up or just the actual thing in your hand right now. Make sure you're in degree mode. Okay, and the reason you're probably thinking to yourself, well, why wouldn't I want to be in radians since my answer has to be in radians? Good call, great question, but here's the problem. Usually when your answer is in radians, you're going to have a pi with it, right? And your calculator won't produce a pi when you ask for the angle. Okay, it's going to just give a long decimal. So that's why we're going to go to degrees. And what we're going to do is to find the angle, if you guys remember back in the day, we're going to do the inverse of tangent. So second tangent, let's get a fraction template out. And in that fraction template, you put the fraction you just created, radical 3 over -1. And then we're going to go, and it's going to tell us the angle is -60. Woo! Radical 3 over -1, -60. Okay, so that's -60 going this way, but it's still 60 degrees. Okay, because remember, reference angles can't be negative, right? Remember that? Reference angles can't be negative. So how can I find this angle measurement right now? Okay, what I'm going to do is, well, if that's 60, how can I find theta? You guys tell me. How can I find what that angle is if I know the reference angle is 60 now? You guys know this now at this point of the year. You know it. If I went all the way around, I'd be going 180 degrees, right? But I already know the reference angle is 60, so I want to subtract that and get a $1.20. Perfect. So my theta is 120, but cannot have it in degrees. I need to convert it into radians. So I'm going to take 120 and multiply it by pi over 180. That was the conversion. All right. Now the only thing I need to do is go to my calculator and reduce the fraction 120 over 180 because I want to keep pi in my answer. So the angle is 2 pi over 3. All right, I know that was a lot of work to find theta, but that's how it's going to be. So our final answer here in polar coordinate was 2, the r value, and theta, 2 pi over 3. All right. So hopefully we're okay there. One doesn't make you great. We got another one here. Now it's 3, -1. What would it be in polar form? So here we go. Go ahead, graph 3, -1. So 1, 2, 3. It's a little spaced out there, but hey, it'll do the job. Boom, there it is. All right, first thing we need to find is what's the r value? This distance right here. So what I need to do is make a right triangle out of this. Okay, now remember, I know you could probably do a couple different ways to do the right, like if you put it over here, you can make a right triangle like that. You can make a right triangle like that, but there's a specific one. Remember our good old days together, first semester? The old bow tie. That's how I remember how to make the triangle in whatever quadrant I'm in. So I'm going to actually draw it up like this. Okay, label your two sides that you know. I got this side 3, this side's 1, but it's negative, right? Because it's going down. All right, here we go, kids. Let's find the r value. 3 squared plus -1 all squared equals r squared. Okay, 9 plus 1 equals r squared. 10 equals r squared. So the r value for this one's going to be the square root of 10, and I'm going to leave it like that. All right, here we go. Now it's on to find theta. And again, to find theta, we always use tangent. So tangent theta is going to be opposite over adjacent. So opposite is -1, adjacent is 3. So our reference angle, here we go. Let's go to the calc. Second tangent, fraction template, -1 over 3. We can round that to the nearest tenth. That's fine. -18.4 degrees. And again, I just told you this in number 2. Reference angles can only be positive. So we're talking about an angle of about 18.4 degrees right here. That's 18.4. What I need is, what's the angle in the fourth quadrant then? Okay, what's that angle in the fourth quadrant? And to do that, theta equals, all right, well, if I went all the way around, it would be 360. But now I got to subtract out that 18.4 to get to the full angle. So theta is going to be 360 minus 18.4, 341.6 degrees. All right, well, let's convert that sucker to radians by multiplying it by pi over 180. And that'll be equal to, let's see, 341.6 over 180. I got a fraction. Can that turn that back into a fraction for me? Yep. 427 over 225 pi. Okay. So my final answer here is going to be, let's see, what was my r value? Radical 10. And my angle, 427 over 225 pi. There we go. Not the prettiest, but it works. Okay, it works. Okay, so again, always use the bow tie to figure out where your right triangle is. Find the reference angle by using tangent. And then either use 360 or 180, depending on what quadrant you're in, to find the actual angle. Okay, don't give up on me here. Do as best as you can. And as you guys know, you can always ask questions at the Google Meets. Good luck, guys.